And welcome to Otten Math. In this edition of Otten Math, we're going to talk about one right angle theorem, and then we're going to take care of a couple of practice problems that involve that right angle theorem. Okay, the right angle theorem, it's pretty self-explanatory, I would say, and easy to understand. And it's theorem number 23, and it could be some other theorem in another book. And the theorem is, if two angles are supplementary and congruent, then they are right angles. So if I have two supplementary angles, I know that those supplementary angles add up to 180 degrees. And if they're congruent, I know that they're the same measure. And if they're the same measure, then it's going to be half of 180 degrees. So I have two angles that add up to 180 degrees. Let's say those are x plus x. They're the same measure, so they both equal each other. So 2x is equal to 180 degrees. And then I know that x is going to be equal to 90 degrees. So let's take a look at an example of a proof that uses this particular theorem. And in this case, I have what's given in the diagram. I have AB that's congruent to CD. I have AB that's congruent to CD, and AD that's congruent to CD. So AB congruent to CB, and I have AD congruent to DC. Well, I also know that BD is congruent to itself. So now I have two triangles, ABD and CBD, that are congruent by side, side, side. Then I'm going to say that angle ADB is congruent to ADB is congruent to CDB by CPCTC. And then I'm going to use my theorem. Angles ADB and CDB are right angles because if the two angles are both supplementary and congruent, they are right angles. Now I want to say, and this is part of the proof, that BD is an altitude to AC. I can see that BD is an altitude to AC because it intersects AC at right angles as we stated as part of the proof. So I'm just going to say definition of altitude. And that's it for the lesson. That's the only theorem to introduce for this particular chapter. Now let's talk about two problems that involve using this concept. The first is I have two lines, A and B, and I want to prove that B is perpendicular to A. So let's just mark the diagram up. I have line B and line A, and I want to prove that B is perpendicular to A. Now I'm given that one angle is 2x plus 37 degrees, another angle is 2x plus y degrees, another is 3x minus 21 degrees. Well, there are a couple things that I can deduce from the diagram. The first thing I can say is that 2x plus 37 plus 2x plus y is equal to 180 degrees. So I can say that B is a straight line, so I know that 2x plus 37 plus 2x plus y are supplementary, and I know that they, in fact, add up to 180 degrees. So I'm going to use that information, and I'm going to solve for y in terms of x. So 2x plus 37 plus 2x plus y is equal to 180. And I solve for y, and I get that y is equal to 143 minus 4x. Well, I also know that 3y minus 21 plus 2x plus y is equal to 180 degrees. Again, these are supplementary. A is a straight line I can assume from the diagram. So 2x plus y, 3y minus 21 is equal to 180. And again, I solve for y in this case. So I get 4y is equal to 201 minus 2x. I solve for y dividing by 4 on each side, and I get y is equal to 50.25 minus 0.5x. Well, I have one value of y that is equal to 143 minus 4x, and another value of y that's equal to 50.25 minus 0.5x. So I set these two values equal to each other because I know that y is equal to y. So I have 143 minus 4x is equal to 50.25 minus 5x. 143 minus 4x is equal to 50.25 minus 0.5x. I figure out that 92.75 is equal to 3.5x. I solve for x. I get 26.5. And then I plug the value of x back into any of these two equations to solve for y, and I get that y is equal to 37 degrees. Now, I can go back to my original equation and figure out what any of the angles are. And in fact, Let's take 2x plus 37. So if x is equal to 26.5 degrees, then I can figure out that 2x plus 37 is going to be equal to 90 degrees. So if this angle here is 90 degrees, then I know that this angle here, using the theorem that I just used, must also be 90 degrees. And then this angle here, because it's supplementary, is also going to be 90 degrees. Okay, moving on to the next problem. Number 15, the ratio of the complements of two angles is 3 to 2, and the ratio of their supplements is 9 to 8. Find the two original angles. Okay, so the ratio of the complements of two angles, so remember, complement of an angle is going to be 90 minus x, or 90 minus some variable. So we'll say the first angle is going to be 90 minus y, and the second angle is going to be 90 minus x. And they're in the ratio of 3 to 2. So I set up my equation. 3 over 2 is equal to 90 minus y over 90 minus x. And my second equation, and the ratio of their supplements, 180 minus y over 180 minus x, is in the relation of 9 to 8. So I use cross multiplication, and I find out that 270 minus 3x, so I multiply 3 times 90 minus x, and that's equal to 2 times 90 minus y. 270 minus 3x is equal to 180 minus 2y. So now again I solve for y in terms of x. 2y is equal to 3x minus 90, and y is equal to 3 halves x minus 45. And I get that for my first equation for y. I do the same thing for the second equation they give to me. I multiply out 9 times 180 minus x and 8 times 180 minus y. And I get 1,620 minus 9x is equal to 1,440 minus 8y. Again, I solve for y. I have 8y minus, or is equal to minus 180 plus 9x, or y in the second equation is equal to negative 22.5 plus 9/8 x. Okay, now I want to set the two values of y equal to each other and solve for x. And I know that when I add and subtract fractions, I need to have a common denominator. So for the first equation, I'm going to multiply 3 halves x by 4 over 4. So I get 12 over 8x. 3 halves x is the same as 12 over 8x. But the denominator here is the same as in the second equation here. So now I can add and subtract those fractions of x. All right, so I want to get x on one side. I'm going to subtract 9/8 from both sides, add 45 to both sides, and I end up with 3/8 is equal to 22.5, or x is equal to 60. Now if I plug x back in to any of the two equations, I'm going to find out that y is going to be equal to 45. All right, so now I have x at 60 and y at 45. I have the two original angles. One is 45 and the other is 60.